Hi there, fellow students and fellow instructors. I'd like to introduce you to my final paper entitled Computer Science Perseveres to Solve Global Water Scarcity. My name is Luis Campos, and I will be taking you on a brief overview of my paper. First off, this alarming fact that I'd like to read to you. According to the Nature Scientific Academic Journal, the amount of people that are lacking access to safe drinking water is 1.2 billion. Methods for increasing that amount of water available for human use are very, very low, especially in Israel and the Middle East. They mostly look towards desalination, which is expensive and very energy dependent, or importing water. So, what is the solution? And it turns out that computer science has seen big strides in what we can do. Basically, this is a chart that's telling you all the water requirements for the certain areas of Israel, and this study was conducted from the desalination requirements in 2010 from the authors as you see there, and it's really alarming. Israel is at a risk, big time. Um, the classes taught me that energy is needed to move water from pipes to homes, but it's also to create energy in dams and other infrastructures. And the production of safe water is very, very difficult. So, computer science software has found ways in this can be fixed. This is a quote from my paper, and it's really an answer, a big picture answer. But water scarcity by rethinking software that calculates the energy requirements of the ammonium carbon dioxide in the forward osmosis process with distillation can be pretty much fixed, or not fixed, but really well thought out. These possibilities include software that can analyze, and it can also develop energy requirements that is simple to read and can take in a lot of data from different areas of the Middle East or anywhere really in the world. This upcoming quote from McGinnis and Elimelech: the thermal and electrical energy requirements of the ammonia carbon dioxide forward osmosis process, also known as FO, were modeled using commercial chemical process modeling software. This software is very state of the art, and I've seen some of the coding behind it. And basically, it's more like a big data structure of just data that um, really models a good way on how to use the energy that is needed for a lot of this process, especially forward osmosis. This is basically not an easy process, as you can see here. Basically, because this is a desalination process, saline water travels through a membrane in which ammonium carbon dioxide solution is drawn into a solute recovery system in which a lot of energy is required. But at the end, your product is water, especially water that can be used for human consumption and other necessities. And actually, before doing a lot of this research, I thought the connection from computer science to water studies seemed like a really big leap. But it turns out the educational research that has been made in the fields ranging from chemical engineering to public health and computer science, they all work as tools in order to solve the issue of water scarcity. If it wasn't for any one of these, the research conducted could not have been possible, and the many different types of solutions that have been found could not have been possible. So it really turns out that all of these areas of study are very, very key into our future, and water scarcity as a general topic that is going to be discussed in years and years to come. Thank you very much.